McDonald's is not a burger company. It's an operating system. I'm Minato. I'm a Tokyo-based engineer, and I don't really look at companies as brands. I look at them like machines, constraints, incentives, workflows, and where things can break. Okay, picture this. It's noon near the Yamanote line. The McDonald's is absolutely packed. People are squeezing past each other, delivery riders are cutting through the crowd, orders are coming from every direction, and somehow it still doesn't collapse. It doesn't feel like a restaurant. It feels like a factory, a high throughput factory that stays weirdly stable. And that's the real thing McDonald's sells, not a Big Mac. A system that can take messy human hunger at massive scale and keep turning it into completed orders with as little friction as possible. So today, I want to take this machine apart. I'm going to break McDonald's into 6 modules, not business strategy modules, more like operating system modules, the kind you'd actually debug. Let's start with Module 1. Module 1, Demand Stabilizers. The product is cheap certainty. Most people think value meals are just promotions. Like, oh, sales are slow, so they discount. But if you look at it like a system, value meals are more like a demand controller. When life gets expensive, people do this annoying thing. They hesitate. They compare. They overthink a $5 decision like it's a mortgage. McDonald's doesn't try to win that game by becoming fancier. It does the opposite. It makes the decision feel safe. Not necessarily the cheapest, just the one where you don't feel stupid after you buy it. That's why they're so obsessive about value. It's not a vibe. It's not branding. It's literally system stability. Because for McDonald's, the nightmare isn't, we made a bit less profit on this order. The nightmare is, you stop showing up. If you don't show up, the kitchen sits there half-used. Staff time gets wasted. The whole system's efficiency drops, and costs get harder to spread. The machine gets weaker. Okay, so Module 1 is basically keep demand steady, keep the factory fed. But then comes the next problem. Even if people come back, how do you make them predictable? That's Module 2. Module 2, digital and loyalty. And yes, McDonald's has membership, just not the Costco kind. A lot of people hear membership and think it's like Costco, pay money to enter. McDonald's isn't that. McDonald's membership is more like free to join, and you earn rewards by showing up a lot. My McDonald's rewards. And from an engineering angle, that's not just points, it's a control layer. Because before, you walked into McDonald's as an anonymous person. Now, if you order in the app, collect points, redeem deals, suddenly, you're not anonymous anymore. You're an identifiable user. And once the system can identify you, it can do 3 things that are honestly pretty powerful. First, it learns your timing, like when you tend to show up. Second, it can nudge you, a tiny incentive. Hey, come one more time. Third, it can shape your choice. You stop browsing the menu and start picking from whatever the system put in front of you. And that's the key. McDonald's isn't trying to make you happier. McDonald's is trying to make ordering easier. Less thinking, less friction, more repeat behavior. But if you're going to talk like an engineer, you can't only talk about what works. You also have to talk about how it fails. Because once every store depends on the same cloud control layer, that control layer becomes a single point of failure. And we've seen this. In March 2024, McDonald's had a global systems issue. Markets like Japan, Australia, the UK, stores were affected, some had to pause ordering. And the company later said it wasn't a cybersecurity incident. It was linked to a third-party configuration change. That's classic overcoupling. Super efficient when everything is stable. But when the control layer shakes, every node shakes. Okay, Module 3, the franchise toll booth. McDonald's isn't selling burgers. It's running a network. Here's the simplest way to say it. McDonald's is a platform. Stores are nodes. Headquarters is the rule maker and the toll booth. Because globally, most McDonald's locations are franchised. And what franchising really means is local operators handle execution. They staff the store. They cook the food. They deal with the chaos at noon. Corporate doesn't do that. Corporate monetizes the network through the brand, the process, the supply chain, and then rent and royalties. So the more stores you have, the more transactions flow through the network. The more corporate behaves like a system that takes a cut. And corporate isn't sitting there worrying, did this one store make fries perfectly today? Corporate cares about the whole network, volume, speed, stability. Module 4, expansion and location. More nodes, more complexity. And here's a thing people underestimate. When you add nodes to a network, complexity doesn't grow in a straight line. It grows fast, like messy fast. McDonald's goal is basically keep the map dense, not just make each store profitable. More like, can we always be inside your daily radius so there's always an entry point? And Tokyo is a perfect example of what it takes to do that. Tokyo stores live on extreme constraints, tiny spaces, huge foot traffic, brutal peak hours. You'll even see two-floor layouts where the kitchen is upstairs, pickup is downstairs, and food moves through this tight vertical path. That's hardware constraint optimization. Space is limited, so the system is forced to create shorter paths, clearer roles, and a consistent rhythm. But once you keep expanding, the system only survives if it does the next thing: simplify. Module 5, speed and simplification, basically organizational refactoring. If you've worked on software, you know this. When a system gets big, the problem usually isn't we need more features. The problem is decisions get slow, coordination gets expensive. You change one thing and 10 other things break. So what do engineers do? Refactor, cut dead code, merge duplicated logic, redesign modules. McDonald's organizational acceleration is the same thing, just in business form. Fewer decision layers, shorter approval paths, lower response time. Because when competition gets intense, especially on value, if you can't move fast, you lose. And from a systems angle, this isn't just cost cutting, it's latency reduction. Lower latency means the system is less likely to jam under pressure. Module 6, the capital return machine. How the system manages energy. You don't need to read financial statements to get this idea. Any machine that runs for decades needs a stable energy source, and it needs to allocate energy correctly, or it dies. McDonald's basically splits energy into 3 buckets. 1, keep expanding and upgrading the system. 2, keep investing in the digital control layer. Less friction, more frequency. 3, return cash outward, so trust in the machine stays intact. So it's not performing well because it gets lucky every year. It performs well because structure compresses volatility. Rules make outcomes repeatable. Now, if you connect all 6 modules into one loop, it's actually pretty clean. Value makes you come back. Digital and loyalty make ordering easier and make your behavior legible. Franchising turns the network into a toll booth that monetizes volume. Expansion adds more nodes and more entry points. Simplification and refactoring reduce latency so the system stays stable under stress. And capital allocation keeps the whole thing funded, upgraded, and trusted. So next time you walk into a McDonald's, I want you to ask a different question. Not, what do I feel like eating? But, how does this place use almost the same rules worldwide to turn crowds into orders into cash flow, and still avoid jamming most of the time? That's what McDonald's is really selling, not burgers. An operating system that turns uncertainty into something predictable. If you like this kind of reverse engineering companies like systems breakdown, subscribe. And next time, we'll tear down another giant machine.